Alright, so let's begin with the next topic, that is the projectile motion. So this is an important topic in the sense that every year there will be one question based upon this. Almost every year there is at least one question based upon this topic. So the name of the topic is projectile motion. So now what is projectile motion? So it's very simple. Suppose you throw something in space, motion of that object is called as projectile motion, and that object is known as a projectile. Okay, so now suppose you have some object, a ball, or suppose this pen, you throw it from this point, you call it an origin. Okay, so this is the origin, starting point, and then at this point suppose you throw this ball in this direction. Okay, so this is the direction in which you throw the ball. So initial velocity is suppose u bar, right? Initial velocity is u bar. Then now what do we want to know about this object is how high does this object go, okay, from the starting position. Then how far does this object go, right? So how high this object goes, that height is known as the maximum height achieved by the object. How far does it go, so that distance to which it goes, it is known as the maximum range. It is known as horizontal range, okay, and maximum value of that is called as maximum range, right? So this is horizontal range, distance covered along the ground. Then after that, what time does it take? So the time that it takes to go to this point, it is known as time of flight. Time it takes to attain the maximum height is known as time of ascent. Okay, and time it takes to go from this point to this point, that is from maximum height again to the ground, it is known as time of descent. So now we want to know all these things. And also we know that if you throw the ball or any object like this, its path looks like this, right? You throw something in air, its path looks like this. So what is the equation for the path, right? So this is a parabola. Okay, this is a parabola. So equation will be something like a parabola, right? Equation of parabola, so standard parabola is y is equal to something, some constant c into x square. This is standard equation of parabola, but then there can be some term having x also. Okay, here you have second power of x, there can be some term having first power of x also. So we want to find out all of these things, right? And again we need to remember them. All right, suppose you throw this ball or any object like this in space with initial velocity u bar. So now this u bar can be resolved in two components. So angle that it makes with the horizontal, it is suppose theta. So this ux is the horizontal velocity, uy is vertical component of velocity. This horizontal component of velocity ux will be equal to u cos theta, right? Remember, component through the angle is cos component, component away from the angle is sine component, right? So ux is u cos theta, uy is u sine theta. And then how can you write the u bar? U bar can be written as ux into I cap plus uy times j cap. Okay, so this is just plain resolution, right? After that, there is an important point to be remembered. Now there is only one force acting on this object if we neglect the force due to air. Okay, that is frictional force. If we neglect that, because it will be very small, so there would be only one force acting on this object when you throw that object in space, that is the force due to gravity, right? So there will be only one acceleration also, that is the acceleration due to gravity, and it is acting in vertical direction. So the vertical component of velocity will only change and the horizontal component will remain constant, because there is no acceleration in horizontal direction. So horizontal component of velocity will remain constant. So this is an important point. So everywhere the horizontal component remains constant. That means at the starting point the horizontal component of velocity is ux. At this topmost point also the horizontal component is ux. At this point it is ux. Ux is equal to u cos theta, right? So this is an important point, right? So then now you can just say that at the highest position, what will happen to the vertical component of velocity? Anyone? At the highest position, what will happen to the vertical component? Tell me. See, if you throw something in space, if vertical component of velocity, if it has some velocity in vertical direction, then it will keep on moving in vertical direction, right? That means it will, that is not the maximum height. If vertical component of velocity is not 0, then that's not the maximum height. Then it will keep on moving further. Okay. So when it attains the maximum height, what will happen? What will happen then? The vertical component of velocity will become 0. This thing is clear, everyone? All right, good. So then if vertical component becomes 0, horizontal component remains constant, then at the maximum height, the velocity is only horizontal velocity, and that is equal to ux, right? At maximum velocity, what, at maximum height, what velocity does this projectile have? It is just the horizontal component of velocity, that is u cos of theta. Okay, just remember that. At the maximum height, there is only horizontal component of velocity, no vertical component of velocity. Okay. After that, next let's see equation for the path of projectile. So see, at start point, let's take x naught equal to 0, y naught equal to 0. Then we know the displacement along x-axis. What is displacement? It is just velocity into time. Why is it velocity into time? Because this is just uniform motion along x-axis. Okay, there is no acceleration. So displacement can be written as final position minus initial position, final x position minus initial x position, that is x minus x naught, and that is ux into t. If you take x naught equal to 0, then you just get x is equal to ux times t. Okay, x is equal to ux times t. That's very, very simple. And from that you can find out time. Okay, the relation between time and x is what? Time in terms of x is t is equal to x divided by ux. Just take that ux on this side. Okay. After that, then displacement along y-axis. Y-axis means vertical direction. So that is uniformly accelerated motion. How much is the acceleration? If you are throwing the object upwards, okay, or at some inclined angle, then what is the acceleration? For vertical component of velocity or for vertical component of motion, the acceleration is vertically downwards. Okay, you are throwing the ball up or throwing the object up and acceleration is down. That means you need to take it as minus g, right? You need to take it as minus g. So displacement along y-axis, you will write sy, okay, y component of displacement, it is uy times t plus half of ay times t square. So because this is uniformly accelerated motion, we used kinematic equation, right? So then what is ay? So ay is equal to minus g. You put that here. So you get sy, which is y minus y naught, is u sine theta into t, that is u sine theta is the y component of velocity, u sine theta into t minus half of g into t square. Okay, and then you put y naught is equal to 0, then you get y is equal to u sine theta into t minus half of g into t square, right? So you get this equation. Then if you put this thing, you want relation between y and x, suppose, then you put t is equal to x upon ux, that is x divided by u cos theta. Here what do you get? Then while when you substitute that, you will get some step in between. Okay, if you put that, so x divided by u cos theta here in place of t, then this u and u will get cancelled. Okay, in place of this t square there will be x square divided by u square cos square theta, and if you do that you will get y is equal to tan theta times x minus half of g divided by u square cos square theta into x square. You get this thing. This thing is clear, everyone? Yes, no? Right? So then what you can do is you can write this as y is equal to tan theta. Since you throw that object with some initial angle, with some initial velocity, so both of them are constants, right? Initial angle is constant. Once you throw it, you cannot change it. Okay, and initial velocity is also constant. So this thing is a constant. Theta is constant means tan theta is a constant. So you can write this thing as alpha, and initial velocity is also constant. So magnitude of initial velocity you cannot change once you have thrown it, right? So this thing is a constant. So you can put some other constant beta in place of this thing. This whole thing is constant. So then you get y is equal to alpha times x plus beta times x square, where your alpha is tan of theta and your beta is minus g divided by 2u square cos square theta. Okay. Then if you look at this equation, you have y is equal to something times x plus something times x square. Something means some constant times x plus some constant times x square, right? So this is called as this is the equation of path of projectile or trajectory of projectile, because it is relation between y and x, right? So if you take some values of x, and for those values if you substitute those values in this equation, you can find out the values for y, and then you can plot the graph between them, and that's why this is known as what? Equation for trajectory or path. Okay, this thing is clear? Yes, no? Okay, and this is an equation of a parabola. Okay, so standard parabola will have equation y is equal to some constant, let's say beta times x square. There is an extra term over here, that is alpha times x, okay, which will extend this parabola. So suppose standard parabola looks like this. Because of this term, this will look like something like this. Okay, so you can say this is an extended parabola, but it's a parabola only. This is this thing clear? Yes, no? Okay, good. So then we need to remember this equation, okay, because it's not I mean, there haven't been questions directly based upon this. We could solve those questions using some tricks, but then you don't know if there is direct question like this. What is an equation of parabola? Option A, B, C, D. Okay, not parabola. What is the equation of the trajectory of projectile? If they ask a question like this, then this is the equation, right? So there might be a direct question also. You don't know. For that sake, just remember this. All right. Then we need to find other things, the maximum height, okay, horizontal range, etc., etc. So for maximum height, we have just discussed what will happen to the vertical component of velocity at maximum height. It will become 0. Okay, and then we can just use this equation, v square is equal to u square plus 2as, right? We can use that equation. V square is equal to u square plus 2 times a into s. Okay, so here we are discussing the y component of velocity, therefore suffix will be y everywhere. Okay, so it is vy square is equal to uy square plus 2 times of ay into s. S is the displacement. So then what is ay? Ay is equal to minus g, so put that here. What is displacement? So displacement from the starting point is just the maximum height, right? Displacement in y direction, it is just the maximum height, so therefore put h over there. So then vy is equal to 0, vertical component of velocity is 0, that means uy square minus 2gh is 0, so ui square is equal to 2gh, and from that you just get h is equal to ui square divided by 2g. And what is ui? So ui is equal to u sine theta. Just put that. So you get h is equal to u square sine square theta divided by 2g. Right? H is equal to u square sine square theta divided by 2g. So this equation also we need to remember. Right? Whatever equations are coming, we need to remember them. Okay. So this one is clear? Yes, no? All right, good. So then next we want to find out the time of ascend. Now what is ascend? Ascend is meaning is clear from the name, right? It's moving up. So time till which it keeps on moving up, the projectile keeps on moving up, it is known as time of ascend. So Vy is equal to ui plus ay into t, we can say. Okay, first kinematic equation. So we are using it for y direction. So what is Vy at the maximum height? It is 0, right? And what is ay? Ay is minus g. So using that, you get Vy is equal to ui minus gt. At maximum height, Vy is 0. Just put that. So this thing is 0. That means ui is equal to gt. If you move this minus gt on other side, ui is equal to gt. And at maximum height, to reach till maximum height, the time that you require, it is known as the time of ascend. So what is time of ascend? It is time required or time taken by an object to reach the maximum height. We denote it by ta, t suffix a for ascend. Okay, just put ta in place of this t, right, for the time of ascend, and then you get ui minus g times t is 0. So t is equal to ta. Then you move this thing on other side, so you get ta is equal to ui divided by g, and you put ui is u sine theta. Put ui is equal to u sine theta, then you get this equation. So time of ascend is equal to u sine theta divided by g. Right? So this thing is clear? Yes, no? Everyone? Okay, good. And then time of ascend and time of descend. So time taken by projectile to go from maximum height to the ground, to come back to the ground, it's same. Okay, these both these times are u sine theta divided by g. Right? How we can find it out, but you just need to trust me over that. Okay. All right. Next is, let's find out time of flight. So what is time of flight? The maximum time for which the projectile is in flight. Okay, it's flying. That is known as time of flight. So how do we find that? So now see, if we are talking about the projectile motion where this horizontal, you can say the ground is leveled, okay, the floor is leveled, then what will happen to the y? What do I mean by y? What will happen to the y coordinate? Okay, so my question is, when you throw some object in air, okay, from the ground, and it is leveled ground, okay, that means it's perfectly horizontal. So when you throw it and it comes back to the ground, so initial y component, or not y component, y coordinate was 0. So what will be final y coordinate? It will also be 0. Right? Yes, no? Okay, so y coordinate will be equal to 0. Okay, so then you have this equation, y is equal to uy times t minus half of gt square, and uy is u sine theta. Okay, so using that equation, put y equal to 0. If you put that, you get u sine theta times capital T. What is capital T? So y will again become 0 when time is equal to what? Time of flight. So that is capital T. So 0 is equal to u sine theta into t, capital T, minus half of g times capital T square. So then move this thing, the capital T, sorry, half of g into capital T square on the other side, or here itself you can take t common. If you take t common, then you have u sine theta minus gt by 2 is equal to 0, Okay, t times u sin theta minus gt by 2 is equal to 0. So this implies that either t is equal to 0 or this bracket is equal to 0. So t is equal to 0 means what? That's the starting position. Okay, so at t equal to 0, y is equal to 0. We know that, but we don't want that. We don't want that case. So if we take the other case, that this bracket is equal to 0, that means if we solve this, then we get t is equal to 2u sin theta divided by g. Okay, just taking this term on other side, we get time of flight is 2u sin theta divided by g, and then this is the total time of flight. This is total time of flight. If you just subtract the time of ascent from it, you get time of descent. So total time is 2 times u sin theta upon g. Time of ascent is u sin theta upon g. That means what remains is u sin theta upon g. So time of ascent is equal to time of descent. Right, this is clear? Yes, no? Okay, good. All right, then next let's talk about the range of projectile. So what is range of projectile? So the maximum horizontal distance to which the projectile goes, the horizontal distance that projectile covers in its motion, okay, in the projectile motion, it is known as range. So this distance is called as range. So what will be range then? It's the horizontal distance that it covers. So what is horizontal distance? It is just horizontal velocity, horizontal component of velocity multiplied by the time that it takes to go from here to here, right? Time that the projectile takes to go from here to here, and that is just time of flight. So you have r is equal to horizontal component of velocity ux, which is u cos theta, and time of flight is 2u sin theta upon g. If you multiply that, you get u times u is u square. U square multiplied by, you have 2 times sin theta cos theta, okay, upon g. And what is 2 times sin theta cos theta? So if you remember half angle formula, okay, or double angle formula, whatever you call it, 2 sin theta cos theta is equal to sin 2 theta. So then you have r is equal to u square sin 2 theta divided by g. This is the range of projectile, right? This thing is clear? Yes, no? All right, very good. So then now suppose I want to find out maximum possible range, that is r max suppose. So for that, this term sin 2 theta must be equal to 1. For maximum horizontal range, sin 2 theta must be equal to 1, right? So put sin 2 theta equals to 1, then you get 2 theta equals to 90 degrees. That means theta is equal to 45 degrees. So at which angle, when you throw an object, at what angle should you throw it to attain the maximum range? So that angle is 45 degrees. Okay, this is clear? Yes, no? Right. So that means suppose you are playing cricket. You will not play at this time, but suppose you are playing cricket, okay, and you want to throw a ball. You are at the boundary, fielding at the boundary. You want to throw a ball, and you want to take minimum efforts. Minimum efforts. So at what angle should you throw the ball to the keeper? So you should throw it at 45 degrees, because when you throw the ball with the same velocity, you're throwing it at same velocity, means let's assume that you are putting on same efforts. You're putting same efforts, right? So you should throw it at 45 degrees. Okay, this thing is clear, because then only it will cover the maximum range. So for the same efforts, the maximum horizontal distance covered is more. Okay, all right, this is how we can apply it in practical life. This thing is clear? Yes, no? Okay, good. So this is range of the projectile. Then, so this is all that we need to remember as far as the equations go. And one more thing, what will be the maximum height? So h is equal to, you have u square sine square theta divided by 2g. So their sine square theta will be equal to 1, right? Sine square theta will be equal to 1. Okay, so maximum height is u square upon 2g. What do you think? When will you have the maximum height? At what angle with the horizontal should you throw the ball? (90°) exactly, right, very good. So you should throw it at 90 degrees to the horizontal. Okay, right, because sine 90 is 1, sine 90 is 1, so sine square of 90 is 1. So then you get h is equal to u square by 2g. Okay, so maximum height is u square by 2g, and maximum range is what? U square by g. Okay, so that thing is covered here. For h to be maximum, you want h maximum, then sine square theta must be equal to 1. That means theta is equal to 90 degrees. And then h max is equal to what? U square divided by 2g. You get that. Okay. So at this angle, at 90 degrees, what do you think will be the horizontal range? When you throw the ball vertically upwards, what will be the horizontal range? 0. Exactly. So horizontal range will be equal to 0. Okay. All right. So then let's see some observations. Equation of velocity when the projectile hits the earth. Okay, let's talk about that. So initially, suppose you're throwing the ball, it's like this. So you throw it at an angle of theta. So now see, this whole curve is symmetric. Okay, this curve means the path of projectile is symmetric. So you throw the ball or any object at an angle theta, it will hit the ground at an angle theta only. Okay, it will hit the ground at this angle. Let's say it hits the ground at this angle. Okay, so this angle will also be equal to theta, right? Okay, if this angle is theta, this angle is also theta. So this is the angle made by its path, or let's say angle made by its velocity, velocity of the projectile with the positive x-axis. Okay, so the magnitude of angle is theta, but now what about the direction? Tell me. Is this thing clear? Yes, no? The question is clear or not? Okay, so question is, suppose the projectile is thrown at an angle theta, it hits the ground, so this angle will also be equal to theta, right? So it's coming, the projectile is coming this way, it's moving this way, right? So then it goes like this. So what will be the angle made by its velocity? Okay, angle made by its velocity with the positive x-axis. So if we talk about the magnitude of angle, it's equal to theta. But then we remember this thing, that if you measure an angle anti-clockwise, it's positive angle. If you measure an angle clockwise, it's negative angle. So then if theta is written and also minus theta is written in the options, which one would be correct? Yeah, minus theta would be correct. Okay, this thing is clear, because you are going in clockwise sense to measure this angle, so minus theta would be correct, right? So magnitude wise theta is correct, but to measure this angle you are going in clockwise sense, So clockwise angles are negative. Okay, this is clear, everyone? Selva Kumar?
Clear, sir.
Okay, good. So it will be minus theta, just remember that. But then now suppose, see, this is the initial velocity and final velocity at this point. So if you apply the law of conservation of energy, the energy with which you are throwing the ball and energy with which it's coming to the ground, because the potential energy will become 0. Okay, potential energy is equal to mgh. Height becomes 0, height here is 0, and when it comes back to the ground, height again becomes 0. So the potential energy is 0. All energy that the ball has, ball or any projectile, it is just the kinetic energy, and that means the speed at this point and speed at this point will be equal. Okay, what else is equal? The horizontal component of velocity at this point and horizontal component of velocity at this point is also equal. Okay, then that means the vertical component will also be equal, right? But there is only one change, that here the vertical component is directed upwards, because this is ascending motion, and when it comes back the vertical component will be directed downwards. Okay, so if here the equation for velocity when it starts can be written as what? It can be written as u bar is equal to ux into I cap plus uy times j cap. This is the equation of its velocity, right? U bar is equal to, you have just resolved u bar into two components, ux into I cap plus uy times j cap. And here what will be the equation for velocity? V bar is suppose equal to Vx into I cap plus Vy times j cap, but Vx is just equal to Ux, right? Vx is just equal to Ux. What about Vy? Vy is equal to minus Uy. Okay, Vy is equal to minus of Uy. This thing is clear. Horizontal component remains same, the vertical component is flipped. Okay, the sign of vertical component will be negative. So suppose this is 2i plus 3j, then what will this be? This will be 2i minus 3j. Right? Got it? Yes, no? Okay, very good. So please remember this thing also, because there can be a question based upon this. And then there is relation between the maximum height and range. Okay, what's the relation between maximum height and range? So this is the equation for range, u square sine 2 theta divided by g. This is the equation for maximum height, it is u square sine square theta upon 2g. If you divide h by r, then what happens is u square will get cancelled. Okay, then one of the sine theta in this square will get cancelled. Okay, and then that one sine theta will remain there. Okay, and g gets cancelled. So what remains is h upon r is just equal to, it is h upon r is just equal to what? Tan theta by 4. Okay, this 2 times 2, it will be tan theta by 4, and if you simplify that, you will get tan theta is equal to 4h divided by r. Tan theta is equal to what? 4h divided by r. Okay, and this is true for any angle. This thing is true for any angle of projection. Tan theta is equal to 4h divided by r is true for any angle of projection. Right? This thing is clear? Yes, no? All right, good. And then there is one more thing. So now suppose equation for the path is given, that y is equal to suppose 5x minus 10x square. This kind of equation is given. So suppose equation for the path is given, y is equal to 5x minus 10x square. This is the equation for path of projectile. So how do we find the range? Okay, so this is your alpha and this is your beta. So the trick to find out range is just do alpha divided by beta. That is, here it will be 5 divided by 10. That means 0.5 meters. Okay, this thing is clear? Yes, no? So the horizontal range will be just equal to magnitude of alpha by beta, 5 by 10. That is 0.5. If this kind of equation is given. Okay, so you can see how does it work. So you have y equals to tan theta times x minus g divided by u square cos square theta into x square. So this is your alpha. Alpha is tan theta, so that is sin theta by cos theta. And what is beta? Beta is equal to this thing. If you divide by this, means you have to multiply by its reciprocal, right? So it's this thing. So then what will happen here? This cos theta and one of the cos theta from the square will get cancelled out, and you get 2 times u square, u square 2 times sin theta cos theta upon g. So that is equal to the range, and you have not taken this negative sign. Okay, so if you do this thing, you get the range. This thing is clear? Yes, no? Okay. So if we remember this, we can find out the range very fast. Otherwise we need to take some efforts. Okay, all right. So this is all the theory that we need to remember. Now let's see some problems. So let us see some simple problems first. Let's see this one. The equation of trajectory of projectile is y equals to 10 times x minus 5 by 9 x square. If we assume that g is equal to 10 meters per second square, then the range of projectile in meter is, tell me. Option C is 18. Okay, let's see. Alpha is equal to 10. Beta is equal to what? Minus 5 by 9. So range is equal to alpha by beta, the magnitude of that, and that is 10 divided by 5 by 9. That 9 will go to the numerator. So this thing becomes 10 times 9 is 90. 90 by 5 means 18. Very good, that's correct. So option C is the answer. Right? So it's very easy to find out range of the projectile. Okay, very good. Then we'll come to this one. This one also. Let's see this. A body is projected at an angle of theta with respect to horizontal direction with velocity u. The maximum range of the body is, tell me. A body is projected at an angle theta with respect to horizontal direction with velocity u. The maximum range of the body is. Yeah, everyone is saying option C. Correct. No, Indusha, it's not option A. Maximum range. So formula for range is u square sine 2 theta divided by g. Okay. For R max will be equal to what? U square by g, because the sine 2 theta, what is the maximum value of sine? It's 1, right? Sine or cos, maximum value is 1. So for R max, sine 2 theta will be equal to 1. So that means R max will be equal to, maximum range will be equal to u square by g. Right, good. So it's option C. Okay. Then during projectile motion, the horizontal velocity, tell me. Option D. Yeah, it's always constant. Right, horizontal component of velocity remains constant because there is no acceleration in horizontal direction. That's very simple. Okay. Then let's see this one. The maximum height attained by a projectile when thrown at an angle theta with the horizontal is found to be half the horizontal range. So maximum height h is equal to half the horizontal range. This is given. Then theta is equal to, tell me what should we do? We have tan theta equals to what? 4h by r, right? It's option A. Let's check. So tan theta is 4h by r, that is 4 times h is equal to half of r, means r is equal to 2 times h. Okay, so h divided by 2 times h, so this thing is equal to 2, right? So everybody got this answer, right? So therefore theta is equal to tan inverse of 2. Theta is equal to tan inverse of 2. Okay, so this is simple, right? Very, very simple. Okay, let's see this one. A bullet fired at an angle theta 30 degrees with the horizontal hits the ground 3 kilometers away. By adjusting its angle of projection, can one hope to hit a target 5 kilometers away? A bullet is fired at an angle of 30 degrees. Okay, and by adjusting its angle of projection, can one hope to hit a target of 5 kilometers away? Assume the muzzle speed to the same and the air resistance is negligible. Muzzle speed remains same, air resistance is negligible. You tell me, everyone, what should we do here? Okay, so let's see. See, you have r is equal to u square sine square theta divided by g, right? And r max is just equal to what? R max is equal to u square divided by g. Okay, then this sine square theta becomes what? Oh, what did I write? Sine square theta. So u square sine 2 theta divided by g. So r max is equal to u square by g. Then the sine 2 theta becomes equal to 1. So now you divide r max by r. If you divide r max by r, what do you get? It's equal to, if you divide by that, then u square by g and u square by g will get cancelled. So this is equal to 1 upon sine 2 theta only, right? This is just equal to 1 upon sine 2 theta. So what is r max? R max is equal to r divided by sine of 2 theta. So just put that. So what is the angle? It's 30 degrees. So r is equal to 3 kilometers, right? 3 kilometers divided by, let's keep it in kilometers only, sine 2 theta means sine of 60 degrees. How much is that? Sine 60 is root 3 by 2. Okay, so take the 2 in the numerator. So the answer will be 3 divided by root 3 into 2, that is root 3 times 2. So 1.73 times 2, right? So that is something like, what is 1.75 times 2 is 3.5. So near about 3.5, you can say 3.5 kilometers. Okay, so can you aim for a target which is at 5 kilometers away? Maximum horizontal range is just 3.5 kilometers, so you cannot aim, right? You can't aim. Okay, it is not at all possible with this speed to reach the target at 5 kilometers. Yeah, very good. So its answer is option B, not possible to hit a target 5 kilometers away. right? So that is very, very simple. Okay, so this thing is clear, everyone? Yes, no? All right, good. So now let us see some recent questions. A bullet is fired from a gun at a speed of 280 meters per second in direction 30° above the horizontal. The maximum height attained by the bullet is. This is from NEET 2023. And they say that it is based upon NCERT, page number 78. All right. So tell me, bullet is fired from gun at speed of 280 meters per second and in the direction 30° above the horizontal. The maximum height attained by the bullet is. So here the direct formula is applicable. H is equal to what? U square sine square theta divided by 2g. So that is 280 square, okay, times sine square of 30 degrees. Sine of 30 square, right? What is sine 30? Sine 30 is half. So square of that will be 1 by 4, is 1 by 4, and then use 2 times of this thing. G is 10, right? So then this thing you want 280 square, so that is 28 times 10 square and 28, yeah, so 28 square. So this thing divided by 4 is, I can say it is 14 square. And what is 14 square? Anyone? 196. 196 times you have 100 from here, okay, and divided by 20, or this thing is 10. 196 divided by 2, so it is 980. Oh, this one maybe 1000 meters, because we took g equals to 10. If we take 9.8, it will be closer, right? Check my calculation if that's correct. Let's get answer from 1 or 2 students. So option C, yeah, everyone is getting option C. Okay, good. All right, so this is direct question and there is nothing difficult in this one if we remember the formula, right? Let's see next one. This is not NEET, RS, some other exam. A cricket ball is thrown by a player at speed of 20 meters per second in direction of 30 degrees above the horizontal. The maximum height attained by the ball during its motion is. So this is exactly, I mean, similar question, and here they asked us to take g equal to 9.8, but that's difficult to do, right? So dividing by 9.8 etc, we're not going to do that. So that's why we'll see the closer options, right? Okay, here a cricket ball is thrown by a player at a speed of 20 meters per second in direction of 30 degrees. So h is equal to u square sine square theta divided by 2g, and that is just 20 square multiplied by sine square theta. This is 20 square multiplied by, you have 1 by 4 because sine of 30 is 1 by 2, and then divided by 2g. 2g is 20. So 1 of the 20 gets cancelled out from here, then 20 by 4 means 5. So answer is just 5 meters. Okay, so this is also very simple, right? Very straightforward. Okay, let's see next one. A ball is projected with velocity 10 meters per second at an angle of 60 degrees, 60 degrees with vertical direction. So this is 60 degrees with vertical direction. Okay, that means 30 degrees with horizontal direction, right? This is from NEET 2022. Okay, so careful reading is required, otherwise we can take theta is equal to, we might take theta is equal to 60 degrees. Okay, that's not true. Its speed at highest point of its trajectory will be, okay, but then again it's not required, because tell me what will be speed at highest point, not the y component of speed. Tell me. A ball is projected with a velocity 10 meters per second at an angle of 60 degrees with vertical direction. Its speed at the highest point of its trajectory will be option A. Okay, let's check. So it is 30 degrees with the vertical means, sorry, 60 degree with vertical means 30 degree with horizontal. Okay, so theta is equal to 30 degrees. Then what is the speed at maximum point, maximum height? It is ux. Ux is equal to u cos theta. So that is 10 multiplied by, what is cos of theta? Cos of 30 is root 3 by 2. So that is 10 by 2 is 5, 5 root 3. Yeah, so that's very simple. Because at the maximum height, what will happen to the y component? Y component will become 0. So what is speed? It is just the x component of velocity, and that is u cos theta, right? So 5 root 3 is the answer. Okay, got it everyone? All right, very good. So a simple question. Let's see next one. Two bullets are fired horizontally and simultaneously towards each other from rooftops of two buildings. So this question was given in the test. Okay, all right, so let us just skip this because some of you have not given test, right? It can be solved without using the concepts in projectile motion. All right, let's see next one. Assertion: the maximum height of projectile is always 25% of maximum range. For maximum range, projectile should be projected at 90 degrees. Tell me which one is correct. Assertion, reason. The maximum height of a projectile is always 25% of maximum range, and for maximum range, projectile should be projected at 90 degrees. So option C, assertion is correct, but reason is incorrect. Okay. All right. So reason is incorrect. That's clear. The maximum range, for maximum range, projectile should be projected at 90 degrees. This is incorrect. If you project it at 90 degrees, it will go upwards and come back at the same point. So range will be equal to 0. Okay, so range is equal to 0. So this is incorrect, right? But then assertion is correct or not? So you know, okay, for maximum range, the angle is equal to, theta is equal to what? 45 degrees. If we take that, then we know tan of theta is equal to 4h by r. Okay, and if you put that angle, so then you get tan of 45 is 1, so 1 is equal to 4h by r. That means what is height? It will be r by 4. Okay, so for this case it is true that h is equal to r by 4, right? Means h is equal to 25% of r. So for this case, if you consider the maximum range and from that you find out the maximum height, then h is 25% of r. Okay, the maximum height when the ball is projected at 45 degrees, then h is equal to 25% of r. Okay, in other cases it will not be true, right? If you change the angle of projection, it will not be true. Okay, so I guess this question is asked this way: you throw a ball in such a way that it goes to the maximum range, then what will be the maximum height, right? So in that case h will be 25% of r. Yes, no? Right, so in that case assertion would be correct and reason would be incorrect. So this is the answer. Okay, but if you change the angle, it's not always that h is equal to 25% of r, right? If you change the angle, okay, but they are saying maximum height of projectile is always 25% of maximum range. So that means you want maximum range, you are fixing the angle, and for that motion you are finding out the height. Right? Okay, this thing is clear? Yes, no? Okay, if you change the angle, this will not hold true. Right? Everyone? Indusha? Alright, good. So if you fix the angle in such a way that it attains the maximum range, then this thing will be true. Okay? Alright, then let's see next one. What is the range of projectile thrown with velocity of 98 meters per second? I guess that will cancel out with 9.8, right? That's why they have given 98, with angle of 30 degree from horizontal. Okay, so this is very, very simple. So r is equal to what? U square sine of 2 theta divided by g. So u square is 98 square. So let's take 98 times 98. Sine of 2 theta means sine of 60 degrees, and you have g. So here we'll definitely take 9.8. 98 divided by 9.8 is 10. So that is 980. 980 times sine 60. 980 times sine 60 is root 3 by 2. Okay, so that is 980 by 2 is 490. 490 root 3. So this is the answer. Right, that's very simple. Okay, then most of the questions will be simple. Let's see next one. When theta is 45 degrees or 135 degrees, the value of r remains the same, only the sign changes. Only the sign changes. Okay, so both assertion and reason are correct, and reason is correct explanation of assertion. Tell me which one is correct. Okay, so now just remember this thing as a fact. If sum of two angles of projection is 180 degrees, if sum of two angles of projection is 180 degrees, then r is same, okay, but on opposite side of point of projection. Okay, just remember this thing as a fact. Okay, we'll solve this, but just remember this thing. Okay, so let's see how. So here what's given, it's theta is 45 degrees and 135 degrees, means theta 1 is 45 and theta 2 is equal to what, 135. Okay, so you have theta 1 plus theta 2 is equal to what, 45 plus 135, it's 180 degrees, right, 180 degrees or 2 pi you can say. So then range in first case, r is equal to what, u square sine 2 theta upon g. Let's find out what is the range in the second case. Okay, range in the second case. So for that, we have r, let's call it as r2. So r2 will be equal to u square by g, that thing is common, multiplied by, you have sine of 2 theta 2. Okay, so that is equal to u square by g multiplied by sine of in place of theta 2 I will put 180 of pi minus theta 1. Okay, and then you can multiply by this 2, so you will get u square by g multiplied by sine of 2 pi minus 2 theta 1, right. Okay, so then this is r2 will be equal to, so what is this thing, sine of 2 pi or sine of, you can say 0 minus 2 theta 1, right, because sine of 2 pi is sine of 0. So this is just minus sine of 2 theta 1. Okay, this is just minus sine of 2 theta 1. You can always replace 2 pi, 4 pi, 6 pi, any even multiple of pi with 0. Okay, and then this formula will be applicable. Sine of 2n pi minus theta is minus sine theta, right. Or if you don't remember, let's just solve it. Okay, so you have u square divided by g, and then you have sine of 2 pi minus 2 theta 1, so that is just equal to sine a cos b. Okay, so that is sine 2 pi multiplied by cos of minus 2 times of what, minus 2 times theta 1, and minus, because there is negative sign here, minus cos of 2 pi into sine of 2 theta 1. Then you know sine 0 is 0, sine of 360 is 0, that is sine of 2 pi is 0. So this first term will become 0, and cos of 2 pi is equal to 1. So the second term will become what, minus of sine of 2 theta 1. So this is just equal to, okay, this thing is just equal to minus of sine of 2 theta 1, right. And then this is minus of u square by u square sine of 2 theta 1 by g. And what is r1? r1 is u square sine 2 theta, or let's say u square sine 2 theta 1 by g. r2 is just equal to minus u square sine 2 theta 1 by g. So if r1 is on right hand side, r2 will be on left hand side, but the magnitude is equal, right. This thing is clear, everyone? Yes, no? All right, good. But then we'll not solve this in exam, we'll just remember this thing. Okay, so let me just comment it. So this is one comment, and there is one another comment that I want to make. All right. So remember this thing. Okay. As well as one more thing. If sum of two angles of projection is 90 degrees, then R is same at and on same side of the point of projection. Okay. So this is for theta 1 plus theta 2 is equal to 180 degrees. Then R is same, but it is on opposite side of point of projection. If theta 1 plus theta 2 is 90 degrees, then R is same and it is on the same side of the point of projection. Okay, this thing is clear? Yes, no? So remember these two things. Right. Okay, let's see next one. If angle of projection of a projector with same initial velocity exceed or fall short of 45 degree by equal amount alpha, then the ratio of horizontal ranges is. Okay, so this is the second case. If angle of projection of a projector, or they should have said projectile, not projector, projectile with same initial velocity exceed or fall short of 45 degrees by same amount alpha. So let's say theta 1 is equal to 45 plus alpha and theta 2 is equal to 45 minus alpha. Okay, then ratio of their horizontal ranges is. So just check what is theta 1 plus theta 2. If they are giving two different angles, just check what is theta 1 plus theta 2. So 45 plus alpha plus 45 minus alpha, so plus alpha minus alpha will get cancelled out. 45 plus 45 is 90 degrees, right? So sum of these two is 90 degrees. That means what is the ratio of the ranges? It's 1 is to 1. Okay, this thing is clear? Yes, no? Everyone clear? Not clear? All right, good. And to check that is also very simple. So see, let's say R1 is equal to u square sine of 2 theta 1 by g, that is u square 2 times sine theta 1 cos theta 1 by g, right? What will be R2? So R2 is equal to u square multiplied by 2 times sine of theta 2. Okay, and what is theta 2? So let's say 90 minus theta 1 multiplied by cos of 90 minus theta 1, okay, divided by g. And then you know what is sine of 90 minus theta? It is cos theta. What is cos of 90 minus theta? It is sine theta. So cos theta times sine theta, okay, again you get the same thing, right? So this cos of 90 minus theta 1 becomes cos of 90 minus theta 1 becomes sine of theta 1, and sine of 90 minus theta 1 becomes cos of theta 1, right? So this is cos theta 1 and this is sine theta 1. So if you multiply that, you get the same thing, right? So this is clear? Yes, no? Okay, good. So just remember those two cases. If sum of two angles of projection is 180 degrees, then R is in opposite direction. It's equal and in opposite direction of point of projection. And if sum is 90 degrees, then it's equal, R is equal, and it is on the same side. Okay, very, very simple. All right, let's see next one. For an object thrown at 45 degree to the horizontal, the maximum height h on the horizontal and the horizontal range are related as. So this is very simple. Anyone? Yeah, it's option C. Right, very good, Yamini. So we should always remember that tan theta is equal to, yes, it's option C. Tan theta is equal to 4h divided by r. Tan theta is equal to 4h divided by r, and therefore this is tan of 45 degrees, which is 1. Okay, so 1 is equal to 4h by r, means r is equal to 4h. So it's option C. Okay, let's see next one. A body is projected horizontally from the top of a tower with a velocity of 10 meters per second. If it hits the ground at an angle of 45 degrees, then the vertical component of velocity when it hits the ground in meters per second is. Body is projected from top of a tower with a velocity of 10 meters per second. Okay, so body is projected from top of a tower with a velocity of 10 meters per second. Okay, it's projected horizontally, right? So body is projected horizontally like this. So it will take a path like this, something like this, and it will fall on the ground. Okay, so it falls on the ground. So how high is this tower? What is given? Okay, that thing is not given. It hits the ground at 45 degrees. This is given. Okay, who can tell me? It hits the ground at 45 degrees. Let's say something like this. Yes, who can tell me this? This angle is 45 degrees. Okay, its velocity is directed at 45 degrees. What does it mean? So velocity is directed at 45 degrees. This is velocity. This angle is 45 degrees. So what will be Vx? Vx is equal to V cos 45. Option A. No. V cos 45. Okay, let me check. V cos of 45. And what will be Vy? Vy is also equal to V cos 45. Right? So both of them are equal, and it is projected horizontally from the top of a tower with the velocity of 10 meters per second. So what is Ux? Ux is equal to 10 meters per second. So we know that in projectile motion, the horizontal component of velocity remains constant. That means Vx is equal to Ux only, right? The horizontal component of velocity was 10 meters per second and it will remain 10 meters per second. So Vx is equal to Ux. Okay, Vx is equal to Ux. But then you have cos of 45 and sine of 45. Okay, this thing will be V sine of 45, but sine and cos of 45 degrees is 1 by root 2 and 1 by root 2 only, so that is equal. Okay, so Vy is equal to Vx and Vx is equal to Ux, means Vy is equal to what? Ux. So what was initial velocity? 10 meters per second. So vertical component of the final velocity will also be equal to 10 meters per second. Is this thing clear? Everyone? Selva Kumar, Purna?
Clear, sir.
Purna, is it clear? Okay, good. Right? So always remember that horizontal component of velocity remains constant, and now if velocity is directed at 45 degrees, means horizontal and vertical components are equal. Horizontal component is constant, that means it is same as that of velocity of projection because it was projected horizontally. So that was 10 meters per second, and here horizontal and vertical components are equal. That means vertical component is equal to also equal to 10 meters per second, right? Okay, good. Simple question if we remember these facts. Okay. All right, let's see next one. A body is projected with an angle of theta. The maximum height reached is h. If the time of flight is 4 seconds and g is 10 meters per second, then the value of h is. Okay, tell me. A body is projected with an angle of theta. The maximum height reached is h. If the time of flight is 4 seconds and g is 10 meters per second square, then the value of h is. Anyone? Option A. Okay, let us check. So what is h? All right, how did you find Yamini? Theta value. Okay. All right, let's see. So see, when you throw a ball, let's say upwards, okay, so it will go to some height and come back, right? So now if you just think about the vertical direction, okay, vertical component of its motion, then it goes to some height, and to come back from there to the ground, what distance does it cover? The distance is equal to h. And what's the relation between this h and the time that it takes to reach the ground? So it is half of g into t square. What is this time? So this t will be equal to time of descent, right? Time of descent. So that is t by 2, capital T by 2. So that is 4 by 2, right? Time of flight is 4, means time of descent is 2. So you got 2 seconds. So then you have half of g is 10 multiplied by 2 square. Okay. So that is equal to what? 20. So answer is 20 meters. Yeah, it's option B. Right? This is clear, everyone? Okay. Is this formula applicable? Is it applicable only when we drop an object, or is it applicable everywhere? it is applicable everywhere, right? You can always consider only the vertical component of motion. Okay, so at whatever angle you project it, you can always consider only the vertical component of motion. So what is displacement in vertical direction? If you just drop a ball from maximum height, it is half of gt square, right? So you drop a ball or you throw it horizontally. Okay, even if you throw it horizontally, what will happen? It will cover same height, right? It will cover same height. So r will be different, but what about h? H will be always equal, right? So you can always use this formula. Okay, this thing is clear, Indusha? Okay, good. All right, let's see next one. The velocity of projection at an initial point A is, the velocity of projection at an initial point A is 2I cap plus 3j cap. Its velocity in meters per second at point B is, tell me, and this is from NEET. Okay, is I guess 21 or something like that. It is option C, right? Very good. Okay, remember everyone, see, we had seen this, that u bar, the initial velocity, can be written as ux into I cap plus uy times j cap, and v bar is suppose the final velocity at point B, so that is vx into I cap plus vy into j cap. So we had seen that this angle is theta, okay, and this angle will also be equal to theta. This angle is also equal to theta, but then at this point, it's going in this direction. Okay, so this angle is the final angle you can say, or the angle that the final velocity makes, right, with the horizontal. So this angle is also equal to theta because it's vertically opposite. So initial angle of projection and final angle, okay, with which it hits the ground, they are equal, but they are just in opposite direction, right? So therefore ux is equal to what? U cos theta. Okay, ux is u cos theta, so it will remain same because cos of minus theta is equal to cos of theta. But what about the sine theta? Uy is u sine theta. What will be vy? It will, in magnitude, it will be also equal to what? Uy. But you know that sine of minus theta is equal to what? Minus sine theta, and that's why direction wise it's opposite. Okay, magnitude wise it is same as that of uy, but direction wise it's opposite. Okay, this thing is clear, and that's why this thing can be written as, now we need to remember this thing. We can of course solve this, but we need to remember that vx is equal to ux, it's ux into I cap, and vy becomes what? Minus of uy. This is minus of uy, minus of uy times j cap. So what was this thing? 2 plus 3, right? I mean 2I cap plus 3j cap. Okay, so this thing will become 2I cap minus 3j cap, right? Okay, very good. So just remember this thing as a fact. All right, let's see next one. An aeroplane is flying horizontally with a velocity of 600 kilometers per hour and the height of 1960 meters. When it is vertically above the point A on the ground, a bomb is released from it. The bomb strikes the ground at point B. The distance AB is, tell me. An aeroplane is flying horizontally, okay, and with velocity of this much, and the height at which it is flying, it's 1960 meters. So let's suppose this is an aeroplane, okay, high tech one. Might look like a fish, I don't know. All right, so it drops a bomb. It drops a bomb. It doesn't drop. It throws. Yeah, it drops a bomb. But since it has some velocity, bomb will also have some velocity, right? Same velocity as that of the aeroplane, and therefore, suppose bomb goes like this. Okay. So the aeroplane is above point A on the ground. It is above point A on the ground, and the bomb, it falls at point B. This is point A, this is point B. So now tell me, what should we do? So this height is given. H is equal to what? 1960 meters. We want to calculate this distance AB. What is given? It's the horizontal velocity. It's flying horizontally. So ux is equal to 600 kilometers per hour. That is 600 multiplied by 5 by 18 meters per second. Okay. So is it divisible? Divisible by 6. So 100 times 5 by 3. 500 by 3. Let's keep it like this, meters per second. Right. Then now what we need to find out is this distance. So we can find out the time it takes to fall on the ground, and for that we can always use h is equal to half of gt square, right? So t is just equal to 2h, square root of 2h by g. Okay. If we move this thing on other side, g on other side. Okay. So from one dimensional motion, we remember that t is equal to square root of 2h by g. Okay. Then put the values. So it is 1960 times 2 divided by 9.8. Right. I guess taking 9.8 will be beneficial. Yes. So 9.8 twos are 19.6. Okay. So this is 2 times 100, that is times 2, that is 400. So you get 20 seconds. Okay. So you get t equals to 20 seconds. And then what will be the horizontal range or horizontal distance covered? R is just equal to ux times t. So that is 500 by 3 times 20. How much is that? Okay, so let's do 500 times 10 is 1000. Then you have 2 by 3. So 2/3 are 0.66. Okay, so 666. Oh, some mistake? $600 by this thing is 600 into 6 times 3, so this will be 100. 100 times 5 is 500. 500 by 3, that seems correct. Then you have twice h by g. Okay, t is equal to square root of 2h by g. Then 1960 19.60 divided by 9.8 is 2. 2 times 100 times 2, 400. Can you spot any calculation mistake in this? Anyone? Last step, this one. So 1000 times 10 by 3. Oh, yeah, yeah. It will be 10 by 3, no? Oh, correct, correct. I'm sorry. So it will be 10,000 divided by 3, right? So that is 3333 meters. So that means 3.3 kilometers. So that's the answer. Okay. So it is option D. Right. So this thing is clear. Solution. Okay. So while you are telling the calculation mistakes and all, you should speak up, no, at least at that time, because I am trying to figure out what's the mistake and you are commenting, right? I mean, you're doing the, you're texting. So I am seeing on my tab. Okay, so my laptop screen is not visible at that time, right? Anyways, so this thing is clear, everyone. I mean this thing. Okay, good. Then let's see next one. An arrow is shot into air. Its range is 200 meters and its time of flight is 5 seconds. If g is 10 meters per second squared, then the horizontal component of velocity of an arrow is. Okay, so arrow is shot into air, range is 200 meters and time of flight is 5 seconds. Then what is the horizontal component of velocity? Okay, tell me. You cannot get question simpler than this. Yes. What is horizontal component of velocity? This is the question. Range is given. Okay. Time of flight is given. So you know that range is just equal to ux times time of flight. So what is ux? Just range divided by time of flight. Right. What is range? 200. What is time of flight? 5. 200 by 5. What's that? 40. So 40 meters per second. This is the answer. Okay. This one is very, very simple. Right? Is there a doubt in this? Anyone? Selva Kumar, is there a doubt in this?
No, sir.
Okay, good. Let's see next one. The horizontal range and maximum height of a projectile are equal. The angle of projection of the projectile is. So we know tan theta is equal to what? 4h by r. R and h are equal, so you can just cancel them out. So tan theta is 4 and theta equals to what? Tan inverse of 4. Right? So again, a very simple question. This is also from NEET, earlier NEET, that was called AIPMT. Okay, let's see next one. A person can throw a stone to maximum height h meter vertically, okay, then the maximum distance to which it can be thrown horizontally by the same person is? Tell me. So what is h if you throw a ball vertically or a stone vertically? Then h is just equal to what? U square by 2g. So tell me, to what distance can it be thrown horizontally? Option C, 2h. Okay, others? Anybody else? So you have r equals to u square sine 2 theta by g. So what is r max? The sine 2 theta becomes 1, so it is just u square by g, right? But h is u square divided by 2g, means this is half of r max, right? So this is 2 times of, I can say, u square by 2g, okay, or it is 2 times of h. This is very simple, right? Okay, good. So let's see next one. The height y and the distance x along the horizontal plane of projectile on a certain planet. Okay, so they are going on different planet with no surrounding atmosphere. So this is also given, there is no atmosphere, are given by y equals to 8t minus 5t square and x equal to 6t, where t is in seconds. The velocity with which the projectile is projected is. Okay, now you tell me what to do. This is little good question. Anyone? Okay, so what you need to do here is just compare it. So x is equal to 16, no? So just compare this thing with x is equal to ux times t. So Nikita is saying it's option A. Let's check. It is not definitely not option A. X is equal to ux times t, and you have y is equal to 8t minus 5t square. So compare this with y is equal to ui times t minus half of gt square. Okay, so what is g on earth? Is 10. 10 by 2 is 5, so it is no other planet but it is earth only, right? Or a planet which is similar to earth, because g there is also 10. Okay, all right. So what is ui? So from this you get ux is equal to 6. Comparing these two, you get ux equal to 6 meters per second, and comparing these two, you get ui equals to 8. ui equals to 8 meters per second, right? So then what is the initial velocity of projection? So u is just equal to, we know it's square root of ux square plus ui square, because u is ux times I cap plus ui times j cap, right? U bar is equal to ux into I cap plus ui times j cap. Okay, so it is 6 I cap plus 8 j cap, but we want its magnitude. Okay, so if answer is given in meters per second, that is not ux or ui, it is the magnitude. So that is square root of ux square plus ui square. That means square root of 6 square plus 8 square. Okay, so 36 plus 64, so that is 100. Okay, So square root of 100 is 10. So 10 meters per second. This is the answer. Right? Okay, good. So again, this question is also not difficult. Right? Anybody from Karnataka? I guess Yamini is from Karnataka, no?
Yes, sir.
Okay, so this is from KCET. Okay, little good question on projectile motion, but it's from Karnataka. Okay, CET. That is engineering exam. All right, let's see next one. The horizontal range of a projectile fired at an angle of 15 degrees is 50 meters. If it is fired with the same speed at an angle of 45 degrees, its range will be. The horizontal range of a projectile fired at an angle of 15 degrees is 50. So you know R is equal to u square sine 2 theta divided by g, right? So you fire it at same speed at an angle of 45 degrees. So speed is same, g is constant, that means R is directly proportional to sine of 2 theta. Okay, so that's very simple. Then you have R2 by R1 is equal to sine 2 theta 2 divided by sine 2 theta 1, sine of 2 theta 1. So that is sine of 2 theta 2. So theta 2 is 45 degrees, means sine of 90 degrees divided by sine of 2 theta 1, sine of 15 times 2 is 30 degrees. Sine 90 is 1, sine 30 is half. So you move that 2 in the numerator. So R2 by R1 is 2, means R2 is equal to 2 times R1. So R1 was 50, therefore R2 is 100. R2 is 100 meters. Right, this is simple. Okay. All right, good. So this proportionality, this is the biggest tool that you can have in solving physics problems. Okay, proportionality is the biggest thing that you can do. I mean, it's very, very simple to do. So if you have some formula, like here also it's u square by g, one is increased by factor of 2, one is decreased by factor of 2. Okay, something like that. Then you should see r is proportional to u square, it's inversely proportional to, here it is g only, but some other factor is there. Okay, then it's inversely proportional to something else. Then what should we do? So if you increase this thing, this is made twice, u is made twice, then what will happen? R will become 4 times, because it is directly proportional to its square. Okay, if it is inversely proportional to something, then if it is made half, then what will happen? Again it will become twice, because it's inversely proportional. Okay, so this is, that is comparison. Okay, proportionality and comparison. So these things, you should exploit these things to get the faster results. Okay, all right, let's see next one. For a projectile, range square is 48 times of maximum height square obtained. Find the angle of projection. Tell me, r square is equal to 48 times of h square. So here what should we do? Again we know tan theta equals to 4h by r, right? So what is r? R is equal to 4h by tan theta, or should we do 4h? 4h is equal to r tan theta. So here we need to h square is there, no? Okay, so here I can write this thing as 3 times 16 times h square. Okay, 16 3s are 48. So then this is 4h square. 16h square is 4h square, right? So 4h square means it is 3 times of r tan theta square, or r square tan square theta, and then that r square will get cancelled out. So then you have tan of theta square, tan square theta is 3, no 1 by 3, and therefore tan theta is 1 by root 3. So what's the angle? For which angle is the tan theta 1 by root 3? (30°), no? Yes, no? So the answer is 30°. Right, this is clear. Yes, no? Okay. All right, let's see next one. A projectile can have same range r for two angles of projection if t1 and t2 be the times of lights in two cases, then the product of two times of lights is proportional to. It has two angles of projection, t1 and t2. T1 and t2 are the times of light in those two cases. Okay, a projectile can have same range r for two angles of projection. So what are those two angles? So first angle is, you can say, theta 1. So second angle must be equal to what? Tell me. Anyone? You want same range, so second angle should be what should be the second angle? (90 minus theta). Good. So that should be 90 minus theta 1, right? So for first one, time of light is 2u sin theta 1 by g. For second one, it is 2u sin of theta 2. Theta 2 is 90 minus theta 1 by g. And then we know what is sine of 90 minus theta? It is cos of theta. So therefore T2 is equal to, then you have T2 is equal to 2u sine of 90 minus theta is cos of theta. So it is cos of theta 1 by g. And then they say that the product of two times, product of T1 and T2, just multiply them. So T1 T2 is equal to 2u sin theta 1 by g multiplied by, it is 2u cos of theta 1 by g. So that is, you have two, so see, you have sin theta 1 cos theta 1 times 2, means that is sin 2 theta, and then you have 2 times u is u square. Okay, u times u is u square, 2 sin theta 1 cos theta 1, so that is sine of 2 theta, or let's say sine of 2 theta 1, divided by, you have g square. Okay, so that I can write like this, g times g. So u square sine of 2 theta 1 by g, this is r, and t1 t2 is 2 by g, this is my g. Okay, this is not 9. Okay, this is my g, this thing times r. So then tell me, T1 T2, they say it's proportional to, it's proportional to what? It's proportional to r, right? Because 2 by g is a constant, that's 1 by 5, right? Simple? Yes, no? Right, it's simple. Okay, let's see next one. The maximum height attained by a projectile is increased by 5%. So h is increased by 5%, keeping the angle of projected projection constant, what is the percentage increase in horizontal range? Okay, tell me. So the formula of h is what? It is u square sine square theta by 2g, and formula for r is u square sine 2 theta by g. So h is increased by 5%, then what should be increment in r? This is the question. Theta is kept equal. So theta is a constant, g is a constant. What is a variable? U is a variable, and then you know that from our first chapter, delta h by h times 100, this is percentage change in h, it will be equal to 2 times of percentage change in u, right? So this is 5%, means percentage change in u is what? It's 2%. This is 2 times of percentage change in u, right? So what is therefore delta u by u into 100, percentage change in u is 5% by 2, means it's 2%. So delta u by u times 100 is 2%. But h is directly proportional to u square, r is also directly proportional to u square, and there is no other power, right? This is also proportional to u square only. So delta h by h times 100 is equal to delta u by u times 100, 2 times delta u by u times 100, and what will be delta r by r times 100? It is also 2 times of delta u by u times 100. So proportionality is same. So whatever percentage change is there in h, same percentage change will be there in r also, because the proportionality on u, both of h and r is same. Okay, both are directly proportional to u square only. So if there is some change in, some error in u, you can say, or some change in u, small change in u, okay, small percentage change, then in both h and r, percentage change would be what? Twice of that of u, right? Yes, no? So that's why answer is 5%. Okay. Oh, this is 2.5%. Delta u by u into 100 is 2.5%. It's 5% by 2. Okay, so this thing delta r by r into 100 is 2 times of 2.5%. But we don't need to do all this maths. So if h is proportional to u square, then percentage change in h is what? 5%. Then change in u must be what? This is equal to 2 times change in u. Okay, percentage change in u. So percentage change in u is 2.5. Okay, and then because its proportionality is same, okay, for h as well as r also, therefore what will be percentage change in r? It will be same as that of h. Okay, we don't even need to write down anything. We can do that all in mind, right? Okay, so our mind should run that way. Okay, so this thing is clear. Yes, no?
Yes, sir.
Okay, good. All right, let's see next. A ball is projected from the ground at an angle of theta with the horizontal. After 1 second, it is moving at an angle of 45 degree. So once they say 45 degree, okay, once they say 45 degree, Vx and Vy are equal. Okay, so at t equals to 1 second, Vx is equal to Vy, right? And after 2 seconds with the horizontal, and after 2 seconds it's moving horizontally, and once they say horizontally, that means what happens is Vy becomes 0. Okay, what is the velocity of projection of the ball? Okay, so let's say v2y equals to 0. This is at t equals to 2 seconds, at t equal to 2 seconds. So this is maximum height, right? This is the maximum height. Okay, Vy is 0, and then what is h? So they have asked about this thing, what is the velocity of projection? So Vy is 0, we can find out what is Uy from this, right? So Vy is 0, so Vy is equal to what? You can see Uy minus Gt. Okay, this thing is 0, that means it is Uy minus, let's take G equals to 10, 10 times what is t? It is 2 seconds. So 10 times 2 is 20, so Uy is equal to 20. So you got Uy equals to 20. Okay, you got Uy 20 meters per second. And then at 1 second, what will happen? Vy is equal to Uy minus Gt. So that is 20 minus G is 10, 10 times 1. So 10 times 1 is 10. So Vy is equal to 10, okay, meters per second. So now this Vy is equal to Vx, okay, because at that time the projectile is moving at 45 degrees. So when it is 45, so V is directed at 45, means Vx and Vy are equal. Okay, so Vx is equal to 10 meters per second. But then you know that Vx is just equal to Ux because it remains constant, it never changes. So Ux is equal to 10 meters per second. And then you can very easily find out what is the velocity of projection. So what is the velocity of projection? U is equal to square root of Ux square plus Uy square, that is equal to square root of 10 square plus 20 square. Okay, so that is 10 square plus 20 square, so that's 500, square root of that. Okay, so 100 times 5, square root of 100 is 10. You have U equals to 10 root 5 meters per second, right? So it is option C. This one is clear.